When we design smart devices and smart systems, it's always a struggle to find just the right connectivity for the job. And the usual suspects don't work very well for a lot of applications. We don't want to go hanging Wi Fi antennas on medicine bottles or have LTE radios and SIM cards to track our library books. And for a lot of applications, we want something that's small, light, inexpensive, and doesn't use a lot of power. And that takes us to Near Field Communication, or NFC. Now, with the explosion of IoT applications, NFC is a great solution for, well, near field communication, it turns out. You can connect just about any device to just about anything at super low cost with zero power on one end of the connection. And that makes NFC ideal for a bunch of applications you might not have considered. Hi, I'm Amelia Dalton, host of Chalk Talk, and I'm intrigued by all of the use cases for near field communication in today's IoT designs. My guest is Mubin Abbas from NXP, and we're going to chat about a number of interesting use cases for NFC that might come in handy in your next design. And before we get started, don't forget to click that link. There you can find more information about NFC solutions from NXP. Hi, Mubin. Thank you so much for joining me.
Hey, Amelia. Thank you very much. It's a pleasure to be here.
So I've heard about NFC for years, but I've never actually used it in one of my applications. So, Mubin, can you give me a quick rundown on where and why I'd use NFC in a design?
Yes, sure. NFC has a wide range of applications. Some of them are discovered, but some are really emerging. Just imagine your toothbrush in the morning. It has a head and it has an NFC application. So you could easily detect if your head has been used or how much the head has been used. If it's already used for a specific number of revolutions, then you need to change this. And what NFC could do is to detect this and send the information directly via an app to your e-commerce or online shop and order it for you. So you don't need to bother for anything.
Cool. Okay. Makes sense. So let's start at the beginning then. What exactly is NFC? Now, I know near field communication, but give me a little bit more about what's behind that.
Yeah, sure. So that's what everyone knows, it's near field communication. But to be a little bit more precise, it's a contactless short range technology which is based on inductive coupling. So which means you could have a detection range of around 10 centimeters. The best part I like about working with the NFC is that it was invented by NXP back in 2002 with Sony.
Very cool.
So, we work on something which originally came from inside NXP. And to be a little bit more feature-oriented, the best feature that NFC provides is the use of power efficiently. So, most of the devices that come today in the market might be battery operated. And in that case, using NFC for different use cases could really help there.
Yeah, power is always an issue with my designs. So what kind of interfaces am I able to do with NFC?
So whenever you have a device or a product and you would like to enable it with NFC, there are different ways to do it. You could start with a reader or a tag depending on your requirements. And then on the other side, you could have another device which could have a reader or a tag depending on the requirements. Or the most common use case, you could have another NFC-enabled smartphone and very easy to exchange the data there. Moreover, you could also use NFC cards and tags.
So there's a pretty big range of ways this can be put together. So I know about uses like payment or security keys like they have in hotels and so forth, but what else is NFC good for?
So the two you mentioned, these are the most common use cases, and in every training I go, when I ask this question, these two come up. But there are several more which we have discovered and which are emerging. So just to mention a few, parameterization and diagnosis is one, mostly focused in the industrial side of the products. Then we have the authentication and identification one. This is mostly on the consumer products, like the one example I gave you of the toothbrush. Then we have the pairing and commissioning, which is also on the consumer products, as well as all the new smart home devices that are coming to the market. And then we have the device-to-device communication, which works mostly in the industrial arena where you have two devices which need to interact with each other.
That's a lot of applications. Okay, so let's talk a little bit about NXP's offerings, especially in the NFC space.
Yes, sure. So we have, I would say, an excellent portfolio in terms of covering the use cases in the market for NFC. So we start with the connected tag solutions. The most common tag solution is the NTAG I2C Plus. The good point about this is it's the easiest way you could enable a device with NFC at a very low cost. So this is why we are trying to push this part to the customers as much as possible and to make them aware of the useful features of this part. The second in line are the NFC front-end solutions. So the NFC front-end solution means you do not have an MCU on the chip, but you have only the front-end solution there. We have several parts here depending on the requirements. So we start from the basic level MFR C630 and SLR C610. Both work on different protocols. So MFR C630 is 14443 protocol and SLR C610 is 15693 protocol. Really depends on what customer is looking for. The difference between the two protocol comes in the detection range. So the 14443 has a detection range up to 10 centimeters and the 15693 has up to 1 meters. Then we move on to the CLR C663 category of products, and there it's a high performance multi-protocol reader. So you have the features of both the basic ones all in one. So if the customer is looking to detect with one reader more protocols, this is where they should go. And then we have the highest in range with some extra features, the PN5180. This is really specialized part, especially also for payment. It has a use in many other applications, but specifically for payment because here we do all the MVCO certifications and compliance. So it's an excellent part when you discuss about payment options. And after the NFC front-end solutions, we have also the NFC controller solutions where you have everything, including an MCU on one chip. We have two different families working there, the PN7150, which could basically work with different platforms, so Linux, Android, WinIoT, and the best part is it has an embedded firmware. So if a customer is looking for a plug-and-play solution, he just picks up this chip, integrates in his platform, and done. For PN7462, that's a specialized and highly customizable part. So this means you could pick this up for high-end customers, and the customers could do a lot of customization to the firmware and use accordingly for their products.
Okay, great. And you said that these are for connected tags. So what about non-connected tags?
Yes, sure. So we do have also a great portfolio with the non-connected tags there, mostly used in closed loop. Closed loop applications mean where you have a reader and tag together. So this is where this comes into play. So we have tags starting from an entry level. The NTAG 210 micro is really, from the name is clear, micro. It's a very small tag in the end. So when you have a space constraint, this is something you would look into and a basic level functionality. Then you start to move higher in the category. So you have the NTAG 213, you have the NTAG 424 DNA. Why we call it DNA, and it's coming soon because it has a really higher level of security. So it has AES security, it has authenticated NDEF messages and encrypted communication. And then we do have the classical traditional MyFair DeskFire products in. On the right side, you could see also the iCode series of products, and these are the Type 5.
So we talked about a lot of application categories earlier, but specifically, what are we talking about today?
I would say the ones where we could have the highest focus could be the parameterization and diagnosis, which comes from the industrial side, and the authentication and identification, which comes from the consumer side. So we could have a mix of both. Let's focus on these two. And then this gives you a flavor of both the industrial and the consumer side.
Okay, that's great. Now let's dive into that parameterization slide. I think you said that there are a lot of industrial applications that use this.
That's true. And you can see there are a lot of pictures here which are from our customers in the market who are using already NFC in their products. So there is a good adoption of NFC for different industrial products, as you can see. A lot of our customers, they are still designing in for new products NFC. And I'm pretty sure that this technology could help the industrial customers ease the maintenance part of their product.
Okay, cool. Do you have a good example you can show me?
Yes, there is a customer called Schmalz. They are using the NFC technology in their vacuum and pressure switches. And we got some stats from them which sound very good and interesting. They say that they reduced their procurement costs up to 40%. They reduced their commissioning times to 75%. And they have 80% shorter service times, which is a good achievement in the end.
Wow, that's impressive across a lot of different kinds of metrics. Okay, now what NXP solutions out of the portfolio you showed me earlier would I be using in a case like this?
So for such a use case where you have parameterization, configuration, a firmware update, or diagnosis, NTAG I2C Plus is the best fitting part. The reason is because it's a very economical part, which means it's a low cost part, and you could replace different mechanical switches which might cost $1 or more to just 20 cents. Also, it has energy harvesting capability, which means you do not need a battery to operate this. Whenever any device with NFC enablement would come near this chip, it would harvest energy and then do the processing. Also, it has a very fast and convenient data exchange. And lastly, we have now put it on a 15 years longevity program, which means we make sure that the customer gets the part for 15 years.
Yes, my manufacturing will like that a lot. So, what would you say is the best NXP product for this kind of use case?
Yes, that's a very good question because we have two really special features with our NTAG I2C Plus, which you will not find in any other product on the market. The first one is called the pass-through mode. The pass-through mode means that you have a possibility to transfer data from the NFC device to the microcontroller in a different way, which could be more efficient. So let's try to break down the structure of the NTAG I2C Plus, and you will see we have an EEPROM inside and we have an SRAM inside. So the pass-through mode means that you do not use the EEPROM for data transfer, but you use the SRAM. So when the microcontroller is awake, all you could do is put the data into the SRAM and it's picked up by the MCU. There are two advantages for this. First, it's really a fast data transfer. The second is that you're not using up the EEPROM. So the EEPROM has a limited number of life cycle. And when you're not using it, this means more lifetime.
Got it. Okay.
And the second one would be the memory configuration. As we have a basic level of security in NTAG I2C Plus, we utilize the memory space for providing more secure information inside. So we have three types of memory areas: the public memory or the unprotected memory access, and then we could divide the rest of the memory into two parts. One which is accessible from the NFC interface and the other one from the I2C interface. And you have the possibility to make them read or write protected. So this means if there's a data that you always want to be in the device for the lifetime, then you could put it in the NFC part and you could make it only a read access.
Okay, cool. Now, you mentioned this earlier, and it seems to me like there are a lot of applications here that are going to involve smartphones at some point. Now, what support is in there in the popular smartphones for NFC technology?
That's right. Smartphone is a very important part of the solutions we pitch in the market, and we have basically two main operating systems, Android and iOS. So Android supports all modes. So when you have Android devices, you have no problems for supporting NFC. Whereas for iOS, it's getting better day by day. And just a few weeks back, they released iOS 12, and this now supports background reading. So you don't need any application, or you do not need to open any application to read an NFC. You could simply tap your mobile phone onto an NFC device, and you're able to read this.
Okay, cool. Let's dive into some development details now. So say I've got the chips. What will I need to do to actually get NFC up and running in my design?
That's another great question and very unique to NXP, because NXP is not only providing chips to the customers. We go beyond silicon. We think beyond silicon. And in that case, we provide a whole lot of solutions and tools for the customer. So, for example, NTAG I2C Plus, we know that the customer needs to design an antenna, and we have several ways to do it. So the first one, customer could go to nxp.com, get the reference antenna design, and start his designs. The second way is we have a series of webinars, so it's around 6 webinars, 6 hours of classes that you could take online, again on our training website, and get your design in. And most of the times, the engineers are able to design their own antennas after they go through this training. The third way is also that we have approved partners, and we could help you engage with them and use them for the designs. They're really the experts. The second thing then would be, after the antenna design, the firmware. For all of our products, including NTAG, we have the firmware already available. So these are the source codes that you could download and start to reuse according to your applications. So it should be no problem. And on the app side, we have the NTAG I2C app available. We have the source code available. You could simply take up this source code, reuse it in the way you want, and easily develop your own app.
Okay, so what development kit options have you got for me if I'm trying to get started putting this into my next design?
That's right. This is a standard we have. NXP with any product would come up with a lot of kits to make life of engineers easy. And we do similar for NTEC I2C+. So we have several kits, the Explorer kits, which you could use for prototyping. We even have the antenna, flex antenna kit. So you could pick up one of these for your antenna designs. And the best part, we have the Arduino compatible kit. So you could just pick up this kit, stack to your Arduino board, and make your developments.
Okay, and earlier you promised to tell me about another use case?
That's right. I said we would focus on industrial and one from the consumer side. So let's talk about the authentication and identification use case.
Okay, so tell me, what are we identifying and authenticating, and why are we doing that?
A good example for this would be the glucose meter. So this was a project from ours in the past where we have a reader inside a glucose meter. That's an NFC reader, and we have a tag on the cartridge. So what you do is when you put the cartridge into the meter, it always detects a few things. So it detects the expiry date, it detects the calibration data, it detects how much it has been used, and also it ensures it's an original cartridge. And all these things, they basically ensure patient safety. They ensure that the results of the device are correct. And moreover, this kind of a design is future-proof because when the glucose manufacturer comes up with a new cartridge, he does not need to change the reader side. He only has to put this data on the cartridge and the reader would calibrate accordingly.
This seems like it has a lot of benefits for my product when it's in the field, and it's not just one thing. So overall, what is this buying me when I finally get my product out?
That's true, and that's also a good question because this implementation of reader and tag will not only be used for the cartridge detection, but when the cartridge leaves the reader, it could go into the inventory and you could have a reader there detecting all your inventory. So for example, the best case would be a hospital with a medical device where you have consumables exactly in the same way. And when these consumables are used and put back into the inventory, you could always detect where they are, how much they were used. You also have the possibility to give access only to the authorized people to these accessories. And moreover, when the system knows that the accessory has been used or is near its expiry date, it could also automatically order this from your supplier. So in the end, with the one implementation, you could go along the process chain for you.
Now, what combinations of solutions from your portfolio would you use in this kind of application?
So we have different possibilities. Like I said, you could use either an MFRC 630 with an NTAG DNA combination, but then you have a proximity or the detection range of around 10 centimeters. But let's say if a customer has a use case where he wants a little bit more detection range, then I would suggest to go towards SLRC 610 with an iCode family of the tags.
Okay, cool. It seems like there are a lot of different options here. Now, what if I want to experiment around a little bit with NFC? It seems like that would be a really good way to get a handle on all of the different choices.
If you ask me about that, the best thing I can suggest is the NFC Nutshell kit. We've recently come up with this new kit, and the idea is that it's really modular. So it has a number of interfaces inside, it has flat cables, it has a number of MCUs inside, a number of readers, and a number of antennas. So what the customer could do is he could pick up one of these kits, he could put the interface he likes, put the MCU he likes, and put the reader he likes, and the type of antenna which suits him, and could fix this together to form a prototype within 3 to 4 hours. The software support is also all available on the website.
Yeah, it seems like that could really help me get my bearings. All right, if I'm ready to get started, you mentioned that NXP goes beyond the silicon to help me get my design done. So, what support does NXP have for me?
Yes, NFC has really good support for the customers. And when I say good support, it means we provide tools for the customers which makes their lives easier to make design-ins for NFC. So for example, one of the main software support we have is the NFC Reader Library. This is a very layered and modular library which can be used for different product families from our portfolio. So what the customer could do is they could just pick up this library, pick up one of the modules and implement this. For example, if a customer is trying to prototype a discovery loop in his applications, he can just pick up this part of the whole library and implement this. So in the end, making the life of the engineers very easy.
Okay, so earlier you talked about antenna development, and I've always worried about this kind of RF stuff. So what can you do to help me with antenna development?
That's a good question, because when we go to the customers and when the customers want to design an NFC, the first question that pops up is, how will we do the antenna? So like I mentioned, we do have excellent resources and ways to do the antenna, but nevertheless, to really test and tune the antennas, we have a tool called NFC Cockpit Configuration Tool, which could really help you to configure and tune your antennas. So this means you have a really fast design of antennas as well.
Okay, so one of my biggest lingering concerns is just the very large number of solutions NXP has in this space. So can you tell me or give me some guidance about how do I figure out exactly what I need for my application?
For the first step, we have a really nice NFC product selection guide. So there you could go in and have a look at the first instance, what kind of a solution you're looking for. Is your solution a passive solution or an active solution? So for example, if you have an active solution and you say your device will communicate with NFC phones, readers, and or tags, then you have to check, okay, what's the level of integration you want to have? Do you have an MCU already there in place, or you are looking for a solution where you need an MCU? So if you say, yes, I need a full NFC solution, then you could probably go for the PN7462 family as an example, where you have all on one chip. But let's say you say, no, I have an MCU and I will use the resources of my existing MCU, but all I need is to work with Linux. Then you could go probably to the PN7150 family, which really has all the integration drivers for Linux. So the selection guide really helps you to figure out at the first instance what kind of product should you look for.
Great. I could see how this could be really helpful to navigate this big field of options. Well, I think that's all I have time for today. Thank you so much for joining me, Mubin.
Thank you very much. It was a pleasure to be here.
And before we go, you didn't forget to click that link, did you? There you can find more information about NFC solutions from NXP. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talk section of EE Journal. Can't miss it, right across the top. Or head on over to YouTube. Keyword EE Journal.